So what are you trying to solve now? What are the challenges now?
Yeah, I mean, we're always, the interesting thing about it, it's a great question, but the interesting about manufacturing is like, that's the mentality. It's not just like, like you have a list of things I want to solve. Like, we watch something going down the line and we're like, why the heck is that taking so long?
Have you ever wondered how successful architecture, engineering, and construction companies scale their business?
Or have you ever wanted guidance on how to get more growth, wealth, and freedom from your AEC company?
Well, then you're in luck. Hi, I'm Will Forat.
And I'm Justin Nagel, and we're your podcast hosts.
We interview successful AEC business leaders to learn how they use people, process, and technology to scale their businesses.
So sit back and get ready to learn from the industry's best. This is
Building Scale.
Hey listeners, it's Will here. Our mission is to help the AEC industry protect itself by making technology easy. If you've ever listened to our show, then you know that the three pillars of scaling a business are people, process, and technology. So if you suspect technology is your weak link, then book a call with us to see where we can help maximize your company's IT and cybersecurity strategy. Just go to buildingscale.net/help.
Today's guest is Roger Krulak, the founder and president of FullStack Modular, a trailblazing company in mid to high-rise modular construction. With over 35 years of experience, Roger has reshaped the industry through his commitment to sustainable, tech-driven building practices. Since founding FullStack Modular in 2016, Roger has led major projects like 461 Dean Street, the world's tallest modular building, and Starwood's first U.S. treehouse hotel. Recognized as a thought leader, he frequently speaks at leading universities and industry events and has been featured in the New York Times, Forbes, and Fast Company. Roger's visionary approach has landed FullStack awards, including spots in Built World's Building Tech Top 50 and Civil and Structural Engineers Rising Stars list. And with all that said, Roger, welcome to the show.
Thank you so much, Justin. Really appreciate it.
Yeah, absolutely. So I said some nice things, but tell us the real story. How the hell did you get into modular construction? I guess it's the easiest question.
You said everything. Drop the mic. There's really nothing else. And yeah, I do appreciate it. And yes, I mean, look, we are design manufacturers of the built environment, and we are focused specifically on housing, whether that be hotels, student housing, multifamily, affordable, attainable, and as you mentioned in that wonderful introduction, that we're really focused on mid to high rise buildings, mostly dense urban environment, because our company was born in New York.
You say New York is a dense environment, is what I heard?
No. Yeah. No, I mean, but the idea of building something that's sort of taller than 8 stories, our system can go up to 45 in a non-seismic, New York area, and it could go up to about 28 in California when you have a seismic, high seismic areas. But it's a very robust all steel system that is structurally very sound and independent of all other structural systems, which makes it a complete system for the building. Just give us a table to sit on, and we do the rest.
Got it. So modular construction is an interesting term. What does that mean to you, and what does that maybe mean to other people?
Yeah, to me, it means like it's not even a starting of a conversation, because modular it has so many things encompassed into it. So modular can be something as simple as like, I'm building wood panel systems to send to a house that's going to be built. It could be a curtain wall system. It could be HVC multi-trade racks. It could be what we do, which is volumetric construction. But the word modular doesn't really tell you anything, and there are so many ways to tell you, I build panelized walls, I build bathroom pods, I build volumetric modular construction with everything in it, or, and that's a better definition of some of the subsets.
So where did the idea come from, or where was the experience coming from that essentially FullStack became a company?
Yeah. Well, the idea of a modular building has had a lot of iterations. I mean, it had sort of post World War II, it had iteration. Number of architects sort of entered into game plans for large modular subdivisions. You have things like Levittown. I mean, there's all kinds of history on modular. The senior project for Moshe Safdie, L'Habitat in up in Montreal. The idea that we could find some way to embrace industrialized manufacturing into the built environment has been a driver for a long time because we have inefficiencies in the process. And one of the things that makes me laugh more than anything is that there's almost nothing that goes into a building, and there's no tool that's used to make the building that isn't manufactured, but the buildings are not. So think about that.
Yeah, that's true.
I mean, you could put a sculpture, like somebody paints a mural, but in general, pretty much the whole thing is manual.
Well, okay. So, you started FullStack Modular. What was your history leading up to FullStack and actually starting FullStack?
How many generations do you want me to go back? No, just kidding. So, I mean, to tell you the truth, my great grandfather was a carpenter, and my grandfather ran lumber yards and was a carpenter, and then he became an executive. My father developed houses, condos, etc. I grew up in Ohio, and the thing that always bothered me, even before I started in the modular, efforts that I have undertaken, is that my great grandfather, may he rest in peace, could go on a construction site today and be totally comfortable with what's going on. Like, there's no other industry where they would not have specific tools to use that increase productivity and accuracy, et cetera. And this industry is getting there, but it is getting there slow, and it's getting there way behind. And so that, and I'm ridiculously impatient. And so the idea of wasting time in meetings, or wasting time waiting for the other trade to show up, or wasting time trying to get up an elevator with your drywall, it's like waiting for a coffee in a Starbucks line, or trying to get to the airport and you don't have TSA pre-check, it's ridiculous. There's a better way.
So you noticed how much time was being wasted really by waiting.
Yeah. And I mean, the reality is the skill sets. I mean, I grew up in Cleveland, Ohio, very union trade focused, location, and those building trades were, they were diminishing significantly. And just pick up any newspaper and you'll read an article about how we are, somewhere between 3.5 million and 7 million housing units short in the United States, and we're losing ground, not gaining ground. So that's, speed is a big deal if you're that far behind.
Okay.
How much faster is modular building in comparison?
Oh, no. It depends on what you're building. So look, I think it's worth noting. No, it's a really good question, and I'm going to answer it, but it has a few facets, and I have a hard time just giving it off the cuff answer. So the interesting thing about industrialized anything, doing something in a factory is that you're striving for economies of scale. So you're trying to do something over and over again with enough repetitiveness that you increase speed, knowledge, and learning in that process. And on whatever spectrum of the scale you fall on is going to be how much savings you have in time once the workers have learned how to do that. So there's diminishing marginal returns. We can do a whole industrial engineering class if you want, but the diminishing, but they're going to get faster and they're going to get highly efficient. And in a factory, because it's incredibly ergonomic, because you're in one place, you don't have to worry about the weather and all that, you get significantly more productivity. So if you do everything really well, you should be able to do it, design and build it in about 50% of the time. If you do it moderately well, you should be able to at least save 25 to 30%.
A lot of time.
That's huge.
A lot of time.
That's
huge.
tons.
Yeah,
From
and we
job
still
costing.
are not going to catch up, but at least it would help.
I mean, industrial manufacturing, at least I don't remember where I saw it, but in a 50-year period, construction saw efficiency gains of somewhere between 10 and 20%. In that same amount of time, manufacturing has gained efficiency by like 675% or something like that. It was just I had to relook at the number.
Yeah, construction has lost productivities in many scales, but and it is trying. I mean, there are all lean construction methodologies, the BIM modeling, the early pre-construction, all of those things do help the efficiency of the process. But the process in of itself is disintegrated. So the nice thing about a factory is it's completely integrated. Like everything has a relationship to everything else. In a construction site, that is just not the case. It just has to coexist, right? So the electrician has to coexist with the work they're doing, and the plumbing has to coexist, and then they have clashes just like you do in society. And those clashes have to yield a result, and it's not exactly what I call great plan, even if it's good.
So talk a little bit about, so obviously time is part of the problem in what you're solving in sort of building modular buildings. Can you talk a little bit more about what are you trying to solve?
Yeah, I mean, it's one of the value propositions. I mean, it's so the interesting thing about the utilization of industrialization, it has some requirements that is antithetical to the process that I just described, which is the sort of design, bid, build process that we've been living in for way too long. And this process, using industrialized engineering, building in the theoretical, requires a paradigm shift to be a more sort of design, build process. And if you can embrace that design build process, and if you can follow the parameters that are created by what it is that you're building, there's a huge opportunity for cost and time savings. And if you're only willing to dip your toe in the water, then chances are the net benefit you're going to get is just like dipping your toe in the water. You'll get a little bit of benefit, but it's not going to probably be the same cost, maybe a little less, maybe you'll save a little time. So the question is, what does the team want to do? If the team wants to build high quality, fast buildings so that people can live in them, you can be looking at, 50% time savings, probably 20 to 25% cost savings. And solving the problem, there's at least 3.5 to 5 million missing units in the United States for people who live in all of the factories we're building all over this country that we've used to build all this brand new manufacturing capacity. There is no houses where any of these factories are. There is nothing to live in. So think about it. Like, it's crazy.
Okay, so when you talk modular, just to give our listeners some concept of how modular and essentially what you are bringing to the table, are you just manufacturing a wall? Are you manufacturing a frame? What are you manufacturing? Essentially, what is it that you are doing at the site? So you've got the manufacturing side, right? And then you bring something over to where the build site is. What is it that you have to do on the site versus what are you doing inside?
So for FullStack, and the name, which I have to credit to my wife, is a technology term related to full stack, engineering. So it's back end programming all the way through user interface and everything in between. Mm-hmm. And that's what FullStack is in the built environment. So we are a fully integrated structural, mechanical, electrical, plumbing system, fully finished in the factory, facade on, all of the finishes, all of the accessories, the hallways, the mechanical distribution. The structural system is part of our system. So we're an all one integrated system. And we do use some sub-assemblies that are also manufactured in industrial.
Okay.
So house in a factory.
Well, yeah, I mean, so we look at the world in a little bit more manufacturing terms. So we look at it in the world of assemblies and sub-assemblies. So like a subassembly would be an electrical, distribution for a unit. It might be a subassembly. A bathroom pod might be a subassembly. A piece of a curtain wall is a subassembly. And then we take those and we assemble those all together. And then we end up with a finished unit that basically just needs to be bolted to the unit next to it. And then all of the kits, all the erector set pieces, that connects them all mechanically, electrically, and structurally come with it as a kit, like you would get in an IKEA box with a bag, and then you put it together.
So, are you creating? So, for all the different types of units that you're making, are a lot of your sub-assemblies the same in all the different units? Is that where the scale comes from?
So, very good question. Let me try to define it a little bit. So we want to minimize repetition. We want to minimize the variations to the extent possible in order to meet the market needs. So that's the balance, right? So if you need 1, 2, and 3 bedrooms to, have a apartment building in Atlanta, and they need to be 1,000 feet, 500 feet, and 700 feet, then we're going to say, hey, look, let's make sure, here's some things we've done in the past, but let's build your optimum 1-bedroom, 2-bedroom and studio, and let's pick 2 bathrooms, the Lux 4 fixture, and then we're going to take those sub-assemblies, and you can mix and match them, but the more variety you have, the less efficiency you get. So you have to choose what's more important.
Okay. So would your company be used more in a master planning situation, like an entire subdivision?
We love that. Doesn't have to be. I mean, you put one building in one place. Like we're looking at some projects in California. High rises. We're looking at obviously we're working on a big project in California for a university with 9 buildings. So yeah, I mean, the value proposition, whether you're putting it in one place or 10 places, because we're building it in the same place, is you want to have enough repetition so that you're getting economies of scale.
Okay. What is the work that has to be done, on site? So you bring whatever it is that you bring from the plant or from the plants over to the construction site. Obviously, it's not a full-on unit or house. So where does it go from there?
Well, I mean, we do mostly multifamily buildings of some sort. So yeah, it does need to be put together, but it is bolt together. The mate line, the kits that connect it are all shipped with the mod. You still have to do a foundation of some sort, steel, concrete, or whatever else, floating boat, whatever, barge we could build it on. We've done, but and then you obviously have to connect to whatever the utilities are, et cetera. That has to happen, and you need a final roof, and you need to drop the elevator in the shaft that's created by building the mods together. So it's really not a whole lot. A lot of connections. It's
okay.
Connections and a final monolithic roof, and obviously a foundation to sit.
Okay. So, there's maybe you take away the weighting. We still need a crane probably to pull up, a lot of the pieces there. I'm going to guess that it's a lot of flat pieces.
No, we are a fully volumetric modular
fully
contract.
Built unit.
Yeah. Pre-finished, prefabricated volumetric construction. It's an entire piece of the building. Now, that piece of the building might be a studio and it's all in one, or it might be part of a 3-bedroom where you have 3 mods that come together and then all 3 of them make one, or it could be a mod with stairs and an elevator. But all of those things come together, built in the factory, fully enclosed, facade on, and then they get stacked on site and then connected.
Okay. It's wild. It's a little bit different from the concept of just building, framing out the outside walls, the inside, right, and all that.
Yeah, it's a very different approach, which requires you to do a lot of planning, and that is different. I mean, the planning is different. The ability to wildly vary everything is a detractor from the value proposition. Obviously, you could do it, but it's a detractor from the value proposition. So you want to have commonality. And honestly, multifamily building has so many parameters to begin with that you're not asking for that much more than you would normally get. I mean, there's a few things, but it really is, it is a good use of something that can be transported and erected.
So what does the people side of this look like, right? So obviously this is construction or manufacturing or a little bit of both, however you want to phrase that. But you're not, I'm assuming you're not taking the normal construction crew and saying, hey guys, sit in this factory for X amount of time and let's see what we get out of it on the other side. So what is, one, who are these people and how do you find them?
So the good news is you do need significantly less skilled labor, although you can use skilled labor, and some skilled labor is very happy there. The nice thing is you get to work inside. You don't have to walk steel. You don't have to go up a man lift. You don't have to do any of those things. You show up the same place every day, have a place to park, go in and do your work, and it's controlled and ergonomic and safe. Never have to get off the ground. And we train them, and we train them with the subset of construction skills needed to create a modular building. And we give them very specific work instructions, which most anybody could understand. And we give them a set of procedures that most anybody could understand. This is what manufacturing of everything else has been doing for 130 years or 140 years. And they just follow those instructions, and it comes out incredibly well. And then, of course, we use a very rigid quality assurance program to make sure that each item is being created as it's supposed to, just like when you order something from Amazon and it comes in and says this hat was quality checked by Josephine. You know, we do the same thing on everything that we build and every piece of it.
So, okay. Help me understand something here, because building modular, you know, even looking at site plans, building modular, I suspect working and looking at the plans looks a little bit differently, because either you're going through them really fast, going through the pages really fast as you're stacking on top, or the plans look completely different than what a normal job site would look like and how you look at that, right?
Yeah. So I think I know what you're asking, and if I answer the question correctly, you can let me know I totally missed it or not. But the actual plans that go into the building department for approval are exactly the same as you would normally have, although some of the systems might be sort of a more modular focused, say, superstructure system, or they might be a modularly focused electrical distribution system that has some specific differences, but still the same drawing.
Okay.
What the difference is that from that point on, normally in a conventional building, you would have the architect then do a series of construction drawings and instructions for all of the trades to follow, so that they can meet the codes that were created in the drawings and that they're compliant, but also be able to give them enough freedom to figure out some ways to be efficient in what they're doing, et cetera. So it doesn't happen in our system. Once there is a permit drawing, we then create level of detail, sort of 400 highly detailed drawings and instructions for all the workers in the factory to follow to make sure that it's compliant with those drawings. We're not relying on, we're creating manufacturing drawings and those drawings. So that is different.
Okay. Are the MEP aspects, right? So mechanical, electrical, plumbing, are they built into the system so even those systems are connected between levels? Is that?
They are. I did mention earlier, and there's the Mateline kit. So the Mateline kits would provide the connection piece, say, between floor to floor. But all the stuff on this floor is done, and all the stuff on this floor is done, and then you just have to fix that. And that's a piece with a couple of connectors, and it's sent in a box, and it has a label, and you can look it up and see what drawing it's supposed to be like, and then you just put it there and connect it, and then you're on to the next.
Holy cow. I suspect that the inner workings or the problems that happen when you have two separate trades trying to work on the same thing at the same time, you just reduced or completely eliminated the problems that from that perspective?
We eliminated it. I mean, when you talk about laying out your manufacturing process for a specific job, you have the choice of how to organize it. You don't have to worry about like when's the plumber showing up or when's the electrician showing up. You're like, first I'm going to do this, and then I'm going to do this, and this is more efficient if this happens first, or maybe we can install the electric on the outside while we're doing drywall on the inside. Like all those things are options when you're in a factory and in a manufacturing environment. Whereas, in a conventional process, you have this parade of trades where certain things can't happen until other things happen. And not saying it doesn't exist, but you have a much more flexibility in how you organize it to optimize it.
So obviously a lot of positives here. It's pretty straightforward. You got time, you got cost of labor. I mean, there's lots of positives here. Obviously newer, so that always you have to have adoption that goes. But why isn't modular? Why isn't everybody saying like I need to be a modular company or a modular construction company?
Well, I don't. That's probably another 3 hours sort of philosophical conversation about how people decide to do something. But the question I think that you really want to get at is like, it sounds great. What's wrong?
Yeah.
If it's that good, like everybody would do it. So there's a few things. One of them is that I mentioned earlier, which is the paradigm shift. The idea of paradigm shift from design, bid, build, that doesn't work much. So if you're starting your process, and if you're a big developer, you've probably been doing that for 25 or 30 years, get an architect, do some stuff for free. You go send it out for pricing, you value engineer it for 5 months, then you value engineer for another 5 months, and then you try to get financing, and then eventually you send it out to a bunch of GCs who basically give you any number you want because they're sick of repricing it. And then, eventually you build it. And by the way, it works, right? We've built a lot of things in the United States. But in order to accomplish modular, you have to do a paradigm shift where you said, look, we're going to design, build this. Like, we're going to figure these things out ahead of time. We want to spend, no more than, 300 for hotels. I don't want to spend more than $300,000 a bed. I can't do that. So that's one of my parameters. And I want it to look ultra modern. That's one of my parameters. And I want to have all one-bedroom suites. That's one of my parameters. And then you as a team, architecture, structural, mechanical engineer, the modular manufacturer, developer, they all come and say, okay, here's our marching orders. And that's so hard for an industry to shift. And it's, 13.5, 14% of the world economy. So it's like not just move it a shift, it's move it an ocean. So that's part of the reason. The other reason is that the enemy, obviously construction is almost always late and almost never on time, right? Mm-hmm. And we keep doing it the same way. And we keep doing it because it's the devil we know, right? So they, so the result of that is like they're not looking for a better way because this sort of works, right? So but that's changing, right? Interest rates went higher, although they just dropped a little bit today. So when money isn't free anymore, you think about how long it's going to take. So money is often a motivator. So you're seeing that pick up, and the reality is that you can't get trades, right? You can't get people to do things, and so forces that that we as humans don't control are driving us to think about things that make sense to solve the problem. And so you're seeing a much bigger pickup. The other thing that is regulatory is really not as big a problem in my view as a lot say it is, but the financing side of it, the other stakeholder, the financing side of it, it's pretty new in the financing world. Like, how do I finance and secure a building that's being built, 500 miles away?
It's really hard. It's really hard to put in those WIP reports.
Yeah, exactly. We do. They have it, and the interesting thing is like we track everything, so you can see like where everything is. But they have to be okay with that. Like the bank inspectors have to be okay with that, and lenders have to be okay with it. So that's really, I think, where the industry is. And I think I can't finish this run-on sentence without saying that residential development is very lumpy, right? And it takes a long time, and it increases in in velocity and decreases in velocity, and that's lumpy. Factories hate lumpy. Like, they want to be busy all the time, 24/7, 365, except for to clean and change the lights and, take off a holiday. You want it going the exact same way because you get your economies of scale. So meeting those two, the lumpiness versus the need to be absolutely consistent, is also a challenge that I don't think has yet been solved. There's lots trying to solve it, but that's the other one of the other elements that I think are sort of slowing down the adoption.
So the financial aspects, there's a huge risk that you can always under create, but then you lose economies of scale. But if you over create, you could actually lose all of your profitability by over creating on whatever your modules are, and that could get you in hot water.
Exactly.
So really what you're saying is, I need to be able to understand what demand is and predict it, because, the Fed does such a great job with that. Understand what the demand is, whether it's pent up or otherwise, and just assume that even things like political factors don't play into this, which...
Of course they do.
Of course.
Yeah. Yeah, no, I mean, yes. I mean, you are correct that you need to find some way to predictably keep your factory busy enough that you are efficient and that you are covering your overhead and making money. And then everything else is gravy. It's like, high, it's high break even, high margin, right? So like the high break even is super hard to hit. And if you have lumpiness and two projects stop, you have an empty factory, you can't just turn the lights off and go home and wait for, if you're a developer with 3 guys, you could send them off to do something. But if you have 150 workers and you're paying rent, in an industrial space, then
they need to keep working. You need, and so really then it's just finding the right buyers.
Or you be your own buyer, or you be your own buyer.
Oh, okay, yeah. Essentially building and then developing and renting out the space.
Vertically integrated solution with a U.S. design, manufacturer, constructor, and there is a reasonable lot of that sort of evolving right now. You'll see.
Gesundheit.
Thank you so much.
So are you guys also in that space? Like, are you building buildings?
We're moving towards that. That's our hope is to get that rolling next year, so that we can keep our factories busy and still build for others, some of the exciting projects, but also do some of our own stuff so that we are always pushing stuff through the factory.
And what does you mentioned? Design build. What is that design? Because I have to imagine that there are limitations, because you want to have the repeatable. Let's just churn out. Like, if I can make 26-story buildings and they look exactly the same in 50 different cities, that's got to be better than this one looks different than that one. This one's different than that one.
Actually, they could actually all look different and be very similar. What I said earlier, like multifamily. Even hotels, I mean, in all honesty, they're pretty much the same pieces of parts. I mean, you could put different lipstick on them, but at the end of the day, bedrooms have to have windows, so, to be legal in most parts of the country, not in Portland, Oregon, but everywhere else. There are a few other places, but they figure you don't need a window because it's never sunny except for in the summer. But I'm just kidding. But they're mostly it's required to have a bedroom has to have a window. Yeah. So you have to have that. Almost everybody feels like they need a kitchen and a bathroom, right? So and the location of those, there's a logical and less logical locations for those same things. So if you incorporate all that, like multifamily is already a shoe into being pretty predictable, as long as you don't go crazy and say, I want 9 different types of 1-bedrooms, because one of them is going to have an alcove and one of them is going to have a big closet, and one of them, that you don't want. But the reality is like, if you want the facade to be different, or if you want the finishes to be different, or if you're like, that's easy. Like you literally just change that out. But if you want every one of the buildings to look different, if you're going to give it to a different architect, then I'm going to have to teach every architect how to embrace modular parameters. Then it's going to take a long time and not be very efficient.
So then the design side has to be essentially inside of the company.
Well, it has to be an integrate. It has to be a design build team.
Integrated.
Yeah.
Whether that team is in one company or whether that team is multiple companies, it still has to be a design build team that is rowing in the same direction.
So you obviously multifamily. That's the space that you work in. What do you see this possible for industrial and other commercial?
There are, there's modular tilt-up buildings been around forever for industrial. Like you can go buy one, you can go online and give specs and they'll engineer it and send it to you. I did that once on a time. Lots of companies that do incredible work in hospitals, operating rooms and exam rooms and portable hospitals. We built a few of the portable, sort of acute care units. I mentioned multi-trade racks earlier, distribution, there's a lot of companies that put, HVAC, plumbing, and electrical in these big unistrut racks, and then you just hang them in a hospital. It saves months, if not years.
Wow.
So there's lots of uses for it. And I mean, to be fair, boats have been built that way for a long time, and airplanes have been built that way for a long time. It's all, it's pretty much the same thing.
So talk to us a little bit about technology.
Sure.
Because I suspect that technology plays a large part in how you guys are building. Talk to us a little bit about that.
Well, I mean, everything. The first thing is, I mentioned in different statements that our process is all built in the theoretical first. Our building information modeling system is a very definitive design of what's being built on site. So every piece, part, screw, detail, et cetera, is created that way. Then that information is conveyed to something. It's either conveyed to the worker on the floor, or it's conveyed to a machine that makes steel studs, or it's conveyed to something that's extruding something. So all of the data is transferable data to communicate with all kinds of things, humans, machines, et cetera. So that's the most important part of it. And then obviously there are ergonomic, space-saving, performance improving tools that also do the same thing, Lincoln Electric's, CNC pipe cutter, or, and all those things are running off the same information. So,
are you designing, are you using BIM or digital twin? You're using BIM. Okay.
It's not a digital twin. I mean, we build off the theoretical, as I explained, we're not on site ever, right? I mean, we send our mods there. We're basically on site. So we're building, here's a design, here's what it has to be, here's how it's all connected, here's how you put it together, here's the code requirements associated with it, and here's the instructions on how to do it, and let's go. So it's all data, and the improvement of data and frankly AI is hugely advantageous. If you think, I'll just give an AI example. I'm no AI expert, but I'll just give you a construction AI example. So let's just say we're building all these walls that hold all of the mechanical systems for the bathrooms that are part of the bathroom. And as code requires, there is a change in the size of the pipe from the first floor to the 10th floor. But but those walls are exactly the same size, and the drain pipe that's running through it is exactly the same size. And then there's some variations in seismic clamps that have to go on, and strain relief, et cetera, so on and so forth. So now you just take that. Here's my base unit on the first floor, and now I'm going to tell the AI these 4 things change, these things stay the same. Now it spits out 3,000 drawings in about 12 seconds, and because you sort of designed it that way. So the answer is, yeah, we used to have to do those 1,000 drawings, with the guy clicking their thing and saying, I'm changing this, I'm changing this, I'm changing this, I'm changing this. So it's a big opportunity. Obviously, if you don't create the infrastructure correctly, if you don't build the model correctly, then it's all kinds of problems. But if it is, then it's hugely evident.
Sounds like you need actually a lot of high skilled labor on the design side, a lot of high.
Yeah. I mean, it is, yeah, it is a big cost and requirement for what we do. Because if it's not super simple to do in the factory, productivity goes down and you don't get your economies of scale. So we expect.
What's the breakout of the team? What's the size of the team, and then what's the breakout design on site compared to the factory?
Yeah. Well, I mean, we have basically nobody on site other than supporting the on site general contractor or owner or whoever it is that's doing it. So that would mean, less than one person. I mean, it's one person for part of the time.
Got it.
But in the factory, all of the assembly is done there. Now, how much of that assembly is actually produced in the factory versus a sub-assembly is produced elsewhere depends on the scale, the time, how busy the factory is. This could be, you can accordion in and out sort of the level of work that's happening in one place versus the other. And then the crew, building, the crews range, you could be as little as 50 people and as much as say 150. It doesn't go much more. And there's usually two shifts. They don't necessarily do the exact same thing, but there's generally sort of two shifts kind of thing. And then there's an astringent QA program that makes sure that we're building exactly what we're supposed to be building. And then there is a production management team, material control, logistics team. Then there's the design for manufacture, VP who manages all the digital process that's required for that. And then there's under him is a person who's working on virtual design and construction, works on AI stuff. And then there's obviously the project manager that's sort of project customer faced. And then there's every other support thing, behind it that you need, accounting and purchasing.
Okay. So, when it comes to the people that are within your organization, you're doing something that's relatively new, right? And so when it comes to training people, so, hey, this is what the rest of the construction industry is doing, that the 14% or whatever of the world is doing, and then there's us, right?
Right.
How much would you rather have someone that's completely inexperienced in construction or have someone that's very experienced in construction coming to your company?
It really depends. Some of each, really. I mean, look, it depends on how many bad habits they have, right? I'll just give you an example. So my great-grandfather was a carpenter, as I mentioned. And, the amazing thing about carpenters, if they're good, especially if they're finished carpenters, they can walk into a house that's been around for 100 years, not a single wall is plumbed, not a single corner is square, not everything. And they're going to take and put in, a 5-piece crown molding that looks like everything is perfect. And that is an incredible skill. And because of that kind of training, they're always looking to solve problems by themselves, right? Because they're left with whatever comes next and they're going to try to solve it. Same thing with a really great painter who goes in and sort of restores stuff, they're going to solve a problem. Manufacturing, that's antithetic. That is totally not productive because we don't want that. If you can't cut your wood at a 45-degree angle and hang it on the wall, somebody before you messed up, and we want to know who it is, and we want to find out why. We want to fix it so you don't have to do it again. So we don't want somebody with bad habits. We love people with skills, but it is a subset of sort of full construction skills. But they are skills. So we like to mix it up a little bit, but you can take somebody. I mean, we have taken people who have literally working at the airport with, the flashlights and turned them into, ultimately they became, A-rate union carpenters working on Hudson Yards, and through our process sort of versus the conventional sort of apprenticeship process. But so it sort of depends on the person and whether they're good at, embracing the process or not.
So you've grown a whole bunch, okay? Without a doubt, successful.
Right.
Do you think that adoption is sort of leaning into modular construction because there's a lot of benefits? Is it really a fear factor in the industry, a fear of change?
Well, I think, I'm going to start talking about fear of change, and we're not going to stop.
Or how does, or in addition, how does the industry have to change, right, to remove that fear?
Yeah, I mean, I think just, I think it's use. The reality is, I mean, I have a couple of sort of touch points. There's no general contractor in the country now that doesn't have sort of like a modular group or a modular division that, works with other modular companies, et cetera. That's a fact. There are public projects like the, California Cal Poly project that I mentioned that is happening. So that's being embraced. So you're seeing adoption, but the things that, that are standing in the way, I said, are, like financing, figuring out how to get banks to understand how this all works. It's pretty easy, actually. It's easy to quantify everything. It's easy to secure everything. It's easy to insure everything, but that's a shift. And so, and then there's, you only need one stakeholder to stop it. And that does happen. It just does. I don't know. Did that answer your question?
No, it did. No, it did. I was just thinking about your comment with the banks, right? Yeah. Not understanding, because you are a combination.
Bank, by the way, and they're very active, and they're learning very quickly, and they're sourcing stuff, and they're doing a really good job. U.S. Modular, and they're doing a good job, and there are other banks that are doing it too as well. Anyway.
Also, modular. It seems that it, big thing that we hear all the time is like labor shortage, right, for construction. But like in your case, that's not inherent. You don't inherently need to have somebody that's extraordinarily skilled. So like that can help the industry as a whole, right? Not just obviously FullStack, but like, hey, like if we have a labor shortage, like here's an idea that then removes that problem. Now again, there's other things you have to do and build it out and have a factory and all the shit that goes with that. But like that is an aspect that like, hey, if we're not having people that are skilled to, go up and build a 50-story building for all the different reasons why there are solutions to this, or at least 45 levels.
Yeah, no, that's correct. It is a response to the need for highly skilled labor.
Interesting. So again, it just goes back to like, well, then there's another reason why you would do this. And eventually the levee will break, one might guess, and say like, it's faster. The labor's cheaper. Also, you can get labor easier, right? Like those things should eventually say like all of these reasons why it should pop over. And so doing more public work, wouldn't that stimulate more people to try to dive in? Like if like the HUD was like, hey, let's build a lot of affordable houses, let's do it modular style.
They've done a few HUD, and they're trying to figure out how to do more. They've spent a pretty good amount of energy and research and money to try to figure it out. So they are focused for sure.
Okay.
So what are the you haven't perfected modular, right? Would that be fair to say? You've definitely made strides, huge strides in modular.
Yeah. Perfect. Yeah. I mean, I think our system is pretty robust and pretty complete, and way more than, sort of most other sort of construction related systems. But,
so what are you trying to solve now? What are the challenges now?
Yeah, I mean, we're always, the interesting thing about it, it's a great question, but the interesting about manufacturing is like, that's the mentality. It's not just like, like you have a list of things I want to solve. Like we watch something going down the line and we're like, why the heck is that taking so long? Like, what's wrong? What could we reorganize? Can we use a different fastener? Like what happens if we move this using wheels instead of a crane? Or what happens if we put the, joists on from the top and we weld the hangers in? What happens if the only way I can answer your question is like, we do that every cycle, every time. Like what's not right?
Continual iteration. Yeah. But you can actually iterate. Yeah. You can actually iterate because you have
Exactly.
At the modular side, right? There are pieces that are the same. And so by making those pieces the same, the manufacturing process that's around it, right, to make that piece, you can iterate to faster, better,
Exactly. And
less
that's,
costly.
like they're like, well, what I love people ask me, what improvements have you made since you started Vector? Like, we make improvements every day. I mean, how long do you have for me to explain this? Like, I can give you some like watershed things that we've done, but the reality is that each one of them, I'll just give you an example. Like we in our last project, it's driving me crazy how long it was taking to put the joists into the floor. And it was like, because you had to stand underneath it, and somebody had to be upside down, and humans don't like to be, and then getting it leveled the correct way. It was super complicated. I'm like, that's crazy. Why don't we just create a joist hanger that we could design that will go, and then we could have the steel manufacturer mark it with their robots and then weld it, and then all we do is drop them in like that, like you drop it in slats to a bed, base or something like that. And that's how we do it. I mean, we save dozens of hours, and it's so effortless. And that, but it doesn't change the structure. It doesn't change what we're using. It does just like the process by which we're doing it is way more efficient. And that's an example. We could talk about them all day, but like that. But that's how you have to think. If you don't think that way. In contrast, I remember when we were first starting the design of this process, and we had a wonderful owner of a plumbing company, and we started to talk about what we were trying to do and what did he think about. And we had some electrical engineers who were helping us, and we were like having all these great, charrettes and think sessions. And we started talking about how we want to just change the way we install the plumbing, and we're going to reverse certain attachment mechanisms, and we think that it'll work. And he stood up and he's like, I do things like my great grandfather did them. I'm not going to change anything. He got really mad and he stomped out. And I'm like, God bless you, and I hope that you stay successful, but he's not somebody who's embracing this. Like, it's just not going to happen. And so, it sort of depends on where you are on that, on that journey.
Would you argue one question? Would you argue that the way plumbing is taught today would have to get then changed? So I'm just going to use your example, right? Plumbing is being taught, and so the thought process behind plumbing, especially if it's unionized, right? There is a very specific way it's trained, done, executed, etc.
Yeah.
So even though you even have union, right? You work with union.
Yeah, we do. Yeah.
There has to be some sway in thought process because it's just done differently.
Yeah.
You're still solving the same problem, but
look, it's all the same pieces at the end of the day, right? At the end of it, it's really how you assemble it. And it really is the process by which you do that. So, for example, and you talked about plumbing, so we'll stay on it. Like, a good old, dyed-in-the-wool union plumbing foreman will tell you that, like, there's nothing better than welding copper pipe, right? Like, it's like, why would you ever do anything else? It never breaks, blah, 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 blah. And that is absolutely true if the material you're using is high quality and if the welder actually knows what they're doing. And that's absolutely true. However, that's not the world we live in. So if you don't have enough welders, you can't put fitters. So we use press fit, right? So like they would say like that's not as good as a welded pipe. I'm like, you're right. If we had, 15 certified welders sitting here on their ass until we needed them and then did that, then that would work really well. But now I can get sort of anybody on my floor to go get that press fit gun, show them 4 times how to do it, monitor how they're doing it, and then all of a sudden, I don't have to worry about welding. So it's more of that kind of process and nuance and adoption of things that work that are really the same things than it is sort of like we're just turning you upside down. I'll give you one more example. So when we built the tallest modular building in North America, we used bus duct, and lots of people make bus duct. Square D is one of them, and I went to Square D and I said, look, you normally put the place that the bus duct is flexible in the center of the floor to floor, and so that it's rigid top and bottom and it's flexible in the middle, and that adjusts for any problems with the building or squareness, etc. I don't want you to do that. I want you to do the flexibility at the floor, because our mods are going to come together, and if they come together slightly off, I'd like them to be able to come together, and then we'll just make it rigid in the middle. And the engineers went, what? I was like, just look at it, please. And they looked at it, and literally 2 days later they came back. They go like, we love this. And they basically I completely reverse engineered their process because it works better for what we do. But it's the same thing. It's adopted. So that's the kind of stuff we do every day. It's like how do we make it better?
Modular methodology is very different. The problems that you encounter and solve, right? There are just, you're trading off. There is a trade-off.
Yep.
I think you solve more problems than you create.
Maybe.
I mean, 50% reduction in essentially costs would argue that you are creating less mistakes and less problems with the process.
Yeah. I mean, look, there's so much to talk about that, because of some of the things that I've talked about. When you're building in the theoretical and you're putting it in the reality, you have to have some way to make sure that reality is matching the theoretical, because you're building in the theoretical. So one of the big efforts that FullStack made at the beginning was, how do you do that? How do you know that you're putting the building exactly the way it needs to be so that everything that you're building in the factory fits?
Yep.
And that's a long conversation, but that is a big focus. So that, and some of the failures that have happened in this industry are much because they didn't figure out how to.
Okay. I appreciate the very nice way of backhanding the industry.
No, it's just, I mean, honestly, it's not, everybody could improve. I mean, if you don't think you can improve, you should really think again. So it's just, but we all know that any failure has a ridiculously high knock-on effect to any successes, right? So it's just important.
So obviously in the construction aspect or the manufacturing aspect, looking for little improvements all the time and changing things all the time makes sense. What about in the business side? I assume the mindset's still the same. Where are places in the business that you're finding those efficiencies as well, or you have over the last 9 years?
Well, we've tried to streamline the process, right? So even our construction contract is different, right? Our success, we have a design build contract that have 3 phases, and we enter this process together in this, agreement that gives everybody the flexibility they need, but also outlines the process. So we have shifted a lot of the sort of agreements and types. And the other thing that's different about sort of manufacturing versus construction is we have a penchant for partnerships versus, competitive bidding, right? So we want to work with people who know what we do and how we do it and what we want to do, rather than having to teach every time, which is very typical. So very typical in a construction environment. Right? It's 5 bids for everything, Okay, but there's a guy one boy knows exactly what we're going to do, and the other 4 have no idea. So it's what's the value and cost of that? So all of those things do shift. I mean, it's the good news is it's like building in Home Depot. Everything comes to our factory. You don't have to be around anything. Nothing. The other thing I think that's interesting that we'll miss is from a traffic perspective on site. Once the foundation is in, you have 70% less truck traffic than you would in a conventional building, because it's all in the mod. It's nothing else. It's just the mod. So
that's a lot of saving. The logistics. That's a lot.
It is. But the cost, the understanding of costs associated with that are quite complicated to unpack and repack, right? Because a drywall guy says, I'll sell you drywall at, whatever, $1 a foot. And they've already included their delivery, et cetera, blah, blah, blah. And now you're saying, okay, send it to me here. And then you have to figure out how to extract the savings that they're experiencing so that's delivered. But sustainably, it's wonderful, right? It's far less. The neighborhood is completely not disrupted after the foundation goes in. No noise, no jackhammers, everything's inside. So it's a you have to work outside. You have to protect the building. So, got to heat it.
Sure. Those are great points. Justin, I think we're run up on time here. I think it's time for our last question.
For sure. Roger, we asked this to everybody, so we'd love to hear your answer. So if you could go back 20 years, what advice would you give yourself?
I think I probably would have told myself three things. One of them is raise way more money. The second one is figure out a way to build some of these projects yourself so that you can perfect it and collaborate with other people, but actually create that as a solution. And then I don't know, those are the two. The three, the last thing I think I try to advocate a lot, but I probably could spend some more time sort of advocating for modular, in the public sector. I think that there's a lot of work to, like, how do we use modular to create affordable housing? It's not, I know how much it costs to build it, but that's not the only problem, right? So how do we create an environment to fund housing that's needed?
So you have to have the manufacturing somewhat nearby in order to.
Yeah, but you also need to be able to finance it in that public sector, which means that the bond funding and the limit of the credit of the person providing that funding, and then how that gets created and how long it takes and all those things. They need to be streamlined along with this in order to really start to make a big difference.
Wow, these are big mountains to move.
Mm-hmm. One at a time. Iterate. Okay. Right. Exactly.
That's awesome. We'll throw all your social stuff in the show notes, but if somebody wanted to get a hold of you, what's the best way for them to do that?
Yeah, you can just go to the website, and there's a connecting, design your own building, have at it yourself, and then there's a link page for information we'll get back to.
Awesome. Anything else you want to tell the people before we say our goodbyes?
Happy holidays.
There you go.
It's exciting. You should definitely explore it. It's an incredible opportunity for us to start to fill the needs of the built environment that we have in this country and all over the world, for that.
Love it. Listeners, I hope you had as good of a time learning about modular as me and Will did. And until next time, adios.
Adios.
Thanks for listening to Building Scale. To help us reach even more people, please share this episode with a friend, a colleague, or on social media.
Remember, the 3 pillars of scaling a business are people, process, and technology.
And our mission is to help the AEC industry protect itself by making technology easy.
So if you think your company's technology pillar could use some improvement, book a call with us to see how we can help maximize your IT and cybersecurity strategy. Just go to buildingscale.net/help.
And until next time,
Keep building scale.
Scale.